Hi everyone, we are located just east of Cedar City, Utah at a location called the Red Hill. Any guesses why it's called the Red Hill? It's very red. Here I want to talk about some basic principles of geologic mapping and the rule of V's.
So if you remember, there are 4 different types of contacts. A contact is a boundary that separates 2 different bodies of rock. And these 4 types of contacts are first, stratigraphic contacts, or you could also call them depositional contacts. Second, fault contacts. Third, erosional or unconformable contacts. And fourth, intrusive contacts. So stratigraphic contacts is a plane that is separating 2 different layers of rock. Where this plane intersects the surface, it forms a line. If you look at a geologic map, you'll notice that there are many lines that form different patterns. These patterns are a result of the orientation or dip of these stratigraphic contacts and the topography that they intersect. You'll notice that in some locations they make parallel lines, and in other locations some of these contacts form prominent wiggles or V's.
Okay, so I've made this beautiful, delicious looking layered Play-Doh cake to help demonstrate these concepts that I'm talking about. So if you look at that, each of these layers are more or less horizontal, meaning that they're at the exact same elevation everywhere, or the contact between these layers is at the exact same elevation everywhere. Now let's see what happens when I remove material from the middle, such as when a canyon is incised. The pattern remains the same. These layers are still horizontal. They still follow the same contour lines or the same elevation lines that they did before. So this sort of example is what you would see within the Grand Canyon. Because the layers of the Grand Canyon are all horizontal, each of those contacts will pretty much follow an elevation contour line. So in this different example, you can see that the layers, and therefore the contact between these layers, is not horizontal, it's tilted. And that creates a much different pattern. So where these contact planes intersect the current surface, it makes a bunch of parallel lines. Okay? Now let's see what happens when a canyon forms in these layers. So these layers will no longer follow the contour lines, and you are left with a prominent V shape inside of this canyon. This is what is referred to as the rule of V's, where you have tilting contacts or strata that intersect some sort of drainage or a ridge.
So the reason we're at the Red Hill is because here we have dipping or sloping stratigraphic contacts and some pretty dramatic topography, which makes it a great location for V's to form. If you look out at the landscape of the Red Hill, can you identify any V's? Now that the V's are identified, can you tell what direction the stratigraphic contact is dipping? Is it dipping towards the camera or away from the camera? You might notice that as the contact moves towards the camera, it is at lower elevations. And as it moves away from the camera, it is at higher elevations. This means that this contact is dipping towards the camera, or in this case, towards the east. This also happens to be the same V's that we see on the geologic map that I showed at the beginning. This is very similar to what you see at Capitol Reef National Park at the Water Pocket Fold. You see prominent V's forming where these slanting or sloping stratigraphic contacts are intersecting these drainages.